Hello everyone, welcome back. So today in this video, I'm going to talk about cryptography overview and the Caesar Cipher, and also the Python implementation of the Caesar Cipher. It's a very basic, simple implementation. That's Caesar Cipher is implemented with the help of the two functions we define in the Python programming language. Let's go to the cryptography overview. It's occurred almost 4,000 years ago just for translating the message. The message translating means from form to another form. That means the messages are replaced, the letters are replaced by another letters or other characters. So when it comes to historical cryptography, that today predate the modern cryptography, which depends on the mathematics. But there are some techniques for scrambling the text, and the cipher is a method used for that. So to scramble the characters, to hide their value, ciphering is the process used at that time. So to do that, there are two types of the non-math cryptography methods. So we will go one by one what were those methods. The first one is the substitution cipher, and that is the cipher text generated from plain text via encryption. So we will see how it is generated exactly in the code, the PT and the CT, what we call as a encryption. We convert each character using that function from the plain text and the ciphertext. Type of coding or the ciphering system that changes one character or symbol at a time, so that one character is converted to whatever the another character or the symbol. So the oldest substitution what we are going to talk about today is the Caesar Cipher method. And the transposition cipher, on the other hand, instead of transposing a single character, we involve the scrambling the letters, and that is the message is broken into the equal blocks of the size and then scrambled. It's little more difficult, but it's still easy because it applies the same approach. Let's go to the Caesar Cipher. It's an example of the substitution cipher, one of the oldest one, purported by the Julius Caesar, that shifted each letters by the 3 places. So here we have a shift value that's we put here by default as a 3. You can change other place if you want. So it simply involves shifting all letters at a certain spaces, say 3 to the right of the alphabet. You already A goes to D, B goes to E, and C goes to F, and so on. We turn A's message into D, B's into E, and so on. So we will see how that is exactly implemented. Code is here. So let me zoom it a little bit so that I can see. So it is a simple definition of the function, as you see, the encrypt letter, where we pass the letter. And we just use the two inbuilt functions. The first one is the ORD function. That means the converting the input character into the ASCII value. We then add the shift. So the shift means the 3 over here, what we have passed. And then we convert back using the CHR function. So the CHR function is normally the function that is an inbuilt Python function that converts the character, that final value, back to the character. And we just return using the return keyword. And the main part is over here. We define an encrypt message function where the input is the plain text PT, where we have test several. You can try more than that also. And the shift, as I said, 3. We print that plain text. The ciphertext we define as an empty string and the counter variable I, and we apply the while loop. If you don't know how exactly the while loop works, please go back and watch my previous video about the difference between the while and for loop. Here I have just applied the while loop. It will go from the I or from the 0 to the length of the plain text. So len function we have applied here. The len function just calculate the length of the message. Over here the length is 3. And over here the length is 5. So it will go every round while the condition is true. So in the later we call the encrypt letter function with extracting value PT of I. So if it is the round 0, round 1, and goes up to there, and that's called the encrypt letter function. So it will encrypt one by one, and then we add that, we concatenate that letter to that empty string, and we increase the counter variable by 1. At the end we just print it, and I have two separate function calls just to show you how that exactly converted. Okay, so I just use the terminal over here. You can directly run from there also. So this time I have used PyCharm to run this, so you can use any other like I did previous with the Google Colab and the online GDP. So here whatever the plain text is ABC, yeah, and we get the output as a DF because we have shifted 3 letters, and whatever the plain text is hello, the output is KHOR. I hope this video helps you, and this is a basic implementation of Caesar Cipher. I will share this code via my GitHub, so feel free to download and play around and work more on that. I hope it helps, and thank you for watching.